Welcome back, chemistry fans. Today, what we are going to do is Unit 9 exam solutions, and these are going to be the free response questions. So let's jump into those 5, and let's see what we can make heads or tails of for you. Okay, so all of these are pretty much fill in the blanks, very somewhat simplistic in nature, but hopefully you'll see how to deal with them now that I help you through this. This is very much like the multiple choice question that popped up. So it says that there's some gas fused 2.5 times faster than the hydrocarbon. So the SO3, and we have some hydrocarbon. We don't know what it is, but we do know that the mass of the SO3 could be added up. So I can add up the weight of sulfur is 32, the weight of the oxygen is 48. So that total comes up to be 80. I don't know what that molar mass is, and that's what we're searching for here. However, it does say that the SO3 is 2 times faster. So this is 2.24 times faster than the other material. So rewriting this, all I need to know is that the 2.24 goes on top and the 1 goes on the bottom. Over here, all I need to know is that there is an unknown weight and that there is an 80 down below. Now, we don't want the square root of this, so I'm going to square both sides so that we get rid of that. So 2.24 squared means multiplied by itself gives me 5.02 equal to x over 80. Multiply that value times 80, cross multiply in other words, and you end up with 401.5 grams per mole is your answer for number 11. All right, number 12, convert torrs into atmospheres. Well, I know that for every 1 ATM, there are 760 torr. So if I have 840 torrs, how many atmospheres would I have? So it sets up as a ratio. So what I'm going to do is I'm going to cross multiply. I'm going to bring the 760 down below. I'm going to bring the 840 over here. So I'm going to end up with 840 divided by 760, and I get that value is 1.105. 1.105. Now, as far as converting Kelvin to Celsius, you subtract 273. You go in the opposite. So 760 minus 273 gives me 487. Converting milliliters into liters, divide by 1,000. So I would end up with 0.0884. Number 13. Calculate the volume if I have liters, temperature, and a second temperature. So I've got to make sure all my temperatures are in Kelvin. So that's 293 K. And so I end up with having V over the starting temperature, 293, sorry, whoops. So I have 478. What I need to know is what happens if it now occupies 156. What's my new volume? So I'm going to cross multiply 4.78 times 156 divided by 293. And I get 2.73 liters. All right, that's 13. So now I'm going to jump to 14. And we are going to do a couple of more or one more of these math equations. I'm asking for a temperature. I've got a gram amounts in 2 different places. I've got a volume and I've got a pressure. So it sounds like I got PV equals nRT. Now you may have been fooled. You may have said, there's 2 of these gram amounts. Yeah, but what that means is you could have solved this twice, or you could just combine them together into the number of moles. I don't have 2 of anything else. So there's no equation where I just have 1 of something and I'm solving for something else. I got to solve for temperature out of this. So I've got a pressure of 6.7. I've got a volume of 3.9. I don't know the moles yet, but I'm going to calculate that. My R value, since I am in ATM, is 0.0821. My temperature is what I'm looking for. So let's now solve for the number of moles. So I'm going to take 451 and divide it by the weight of oxygen. 451 divided by 32 gives me 14.1 moles. And then over here, I'm going to divide by the weight of nitrogen. 375 divided by 28 gives me 13.4. So I add those two values together. So 14.1 plus 13.4 gives me 27.5. Now I'm solving for my T. I divide both sides by that value, by the values. 0.0821 and 27.5, and that will leave the temperature all by itself, which is what I want to solve for. So 6.7 times 3.9 divided by 0.0821 divided by 27.5, and I get 11.6, what am I in, Kelvin? Very small value, very tiny. All right, which has a higher boiling point, BR or ICL? All right, well, if I have two elements that are exactly the same, A, they're not polar, so there's no dipole-dipole. B, there's no dispersion forces, pretty much because they're the same size. There may be some, but that's not a whole lot. And then there is no hydrogen bonding. But with ICL, we do have a difference in size. So we're going to see a higher boiling point with this one because we have a dipole-dipole moment. You could also talk about there being a larger dispersion force on this one because it can stay longer on one side than it can on the other, and that's going to help it create more forces to stick together. It's going to have more of a positive and a negative side, more negative over here, more positive over here, and that's going to cause it then to want to have a higher boiling point. All right, the exact same story. Who has higher dispersion? It's going to be the one with the larger molecules because it has more atoms, more electrons rather. And so if I have 70 electrons on one side, that's a much higher dispersion than if I have just 2 on one side. That's going to be a much weaker force over here. Finally, stronger hydrogen bonds, you're looking for NOF. Well, if you see that right there, the NOF is bonded to an H, you know that you have a stronger intermolecular force. You do not see any of those that are hydrogen bonds on this one. All right, thank you very much for your time. I will talk with you again soon. Hope you understand the process a little bit better. Bye-bye.